Welcome everyone, welcome WarsawJS 22, and thanks for inviting me here. We've had already 2 interesting presentations. Now it's time for JavaScript plus Java equals TypeScript. If you don't know Java, don't worry, you're gonna benefit from this talk anyway. So, my name is Tomasz. On a daily basis, I work on designing architecture and developing enterprise interfaces for a Cybercom Poland company. For over 2 years, I've been working for a financial sector, precisely banks, and the experience I've gathered throughout the years is what I want to share with you today. Moreover, I speak here and there, and I do trainings and some other stuff as well. And I contribute to open source, but it will be, I'll speak about it later. So, the topic of today is TypeScript. First, we're gonna take a brief overview of what TypeScript is, but it's gonna be quite short. Then we will just step back to see how does TypeScript fill into the landscape of all the JavaScript tooling, right? Because this is very dense recently. Then we go to the main point, which is the problems. The problems in everyday JavaScript development that TypeScript solves, and the problems it doesn't solve. Then we'll see how does TypeScript find its place among its rivals, so it's native JavaScript, the upcoming standard ES6, and CoffeeScript. And finally, we would make a summary, what are the profits and losses of using TypeScript. Okay, so my first question to you is, what is your TypeScript experience? Hands up, who knows what is TypeScript? Okay, so it's almost everybody in the room. How many of you have used TypeScript? At least did npm install TSC? Okay, still quite many people. And who is using TypeScript in production, like commercially? Okay, I can see maybe 6, maybe 7 people. So you're the perfect audience. You're mostly familiar with what TypeScript is. And now we're gonna speak about what benefits we can get from it. So my experience with TypeScript is 2 big projects. One of them is Portal Bank, the thing I do for money, for my living. This is a banking application that has been done for over 120 Scandinavian banks. So this is for Denmark, Sweden, Norway, excluding Finland, but including Faroe Islands that always get mad when we forget about them. So the Portal Bank is an application for the banks written in TypeScript and in Angular, and it's deployed over 120 different instances in different banks with different functionalities, different look and feel, and so on. And it took us over 1 year to reach the production, right? From the moment that we have started replacing old GSP, old Java stuff until we made it. So this is the first project. The second project is JSON Schema Faker. This is an open source project that I'm one of the core contributors. This is a massive fake data generator. It's a tool that you can define JSON schema. JSON schema is a standard that you define what is the content available in a JSON, so that you can define, let's say, customers, addresses, or some kind of very specific types of JSONs, and this tool will generate the data for you using it. And this project is already over 2 years old, and at some point we've had so much, let's say, difficulties in maintaining it, in finding what are the tweaks in the code, that it started to be really difficult, and that was the moment that we decided to migrate it to TypeScript. It took us like a few weeks to do it. The code base is not that big, and it was done in 3 months ago, in March 2016. And since then, it's a lot easier for us to deal with the bugs and to add new functionality. And it's also a lot easier for newcomers, new contributors, to reason what is going on in the code. And by the way, a small advertisement. If you were thinking about joining any kind of open source project and you didn't know what to join, please feel welcome, and we are looking for contributors. So if you want to help us in making JSON Schema Faker better, then just call me anyway. And this is the links. I'm going to grab the links to, through Twitter and Meetup.com. So, what TypeScript is, in short. So, let's say that we have a function, just a pure JavaScript function. It has two parameters, an object and at a times. This function is going to grab an object, multiply it a few times. The number of times is the second parameter, and it's just going to return the array. This is just pure JavaScript. So what we do, what we use TypeScript for, is that we can define the types, right? What is it going to be? So we can define that an object is just going to be some kind of an object, right? And the times is going to be just a number, right? Whether it's an integer or a float. TypeScript defines just a number. So we just add a semicolon, we define a type, and here it is. We can do it for the input parameters. We can also add it for the output parameters. We define exactly the same way with a semicolon and a return type. What is it going to be, right? And this is information for TypeScript when it's going to assign variables to function calls and the other way around, right? And if TypeScript finds that there is some kind of error in between, then it will fail. It will say that, hey, there is an error. You're trying to do something you didn't intend to. Okay, so we can define input types, output types. We can wrap our code in a module so that we can provide namespacing, right? So we should all probably know that polluting global scope is evil, right? Yeah, I can see people smiling. So this is quite easy to be done within TypeScript. We can always create classes. We can create private accessors, public accessors, protected accessors. We define constructors. We can define those accessors for variables, for methods, and so on and so on. Yeah. So this is a brief overview of what TypeScript offers. Of course, it offers a lot more, but this presentation is not about the features. It's about the benefits, the pros and cons. So mainly, TypeScript is about classes, interfaces, modules, generics. They work exactly the same way as they work in Java and .NET. TypeScript is the source language, right, that is going to be transpiled down to JavaScript so that the JavaScript is going to be executed, right? So here we are introducing something called compile time. How many of you have been working with strictly type languages, just like Java, .NET, C++, C? Okay, most of you. So for those of you who haven't done it so far, in JavaScript we've got just the runtime. If we make an error, whether it's our fault or the server's fault, we will get the error in runtime. And when we introduce TypeScript, some of the errors might be found in the compile time, right? If the code has some kind of logic problems. And finally, TypeScript is maintained by two giants, Microsoft and Google. TypeScript has been initially created by a Danish guy, I guess, from Microsoft. After some time, Google joined Microsoft, and they're extending this language together. And you can imagine how powerful it might become when you have Microsoft as your mother and Google as your father. This language is becoming really, really hot and popular. Okay, so let's implement this object range method. So we have already defined that this object range function is gonna multiply an element and return an array of this multiplied elements. So here we will introduce also generics. A generic, who knows what this is? Okay, most of you. For those of you who don't, we are just making some kind of a pattern that whatever type we put here, this is going to work exactly the same, right? But we don't have to copy, paste each definition. So we just create it once, and we will just reuse it. So internally, we create a variable result. Again, semicolon, this will be an array of elements of type T, which is the generic, and we instantiate with just an empty array. We just do a for, we call a result push of the object, and we just return the result. So this is just a typical function you might do in TypeScript. Now, we add a module that is called cache, whatever this is, and we've got an interface that is called payment, whatever this is. We define an interface to state what is going to be the content of a variable, of an object, right? So here we define that it has to have an amount variable that is of type number and a count variable that is going to be a string. So when we create variables and we want to assign it to a specific type and we don't provide amount or don't provide a count object, then it will just throw an error, right, during compile time. TypeScript will not allow us to work with the code that is just illogical, right? Just the same as in Java and .NET and C++ and so on. So we've got the function, we've got the module with the interface. Let's do something with it. This is just the header of the function. And we may just use this generic. So we create a var payments. This is going to be an array of this payments type. So we call object range on cache payment type. And we pass the object, which is just some kind of amount, a count with a string, and 5 times, and we just console log it, and we've got the array of elements. So this is just a brief, very brief overview of what TypeScript offers us. And if we take a look at JavaScript and Java, some kind of major differences between those languages, we will see that JavaScript is weakly typed, Java is strongly typed, right? JavaScript is strictly asynchronous and single-threaded language, whereas Java is mostly synchronous. Of course, you can write parallel Java, but when you write the code in Java, you think mostly in terms of, sequential processing, like an operation, then another operation, and then another operation. And this is completely different in JavaScript when you need to know like what is gonna be executed in what order, right? In Java, you write asynchronously very rarely. Then, JavaScript is mainly a functional language, right? It is object-oriented somehow, but it's mainly functional, whereas Java is just a pure OOP approach. JavaScript is prototype-based. In ES6, we don't have classes, and Java is a class-based language, right? This is the classical OOP approach with classes. And finally, JavaScript is used for both clients and servers. The servers can be done within Node.js that Artur has been talking about before. And in Java, we can do server-side. There was an approach to clients in Java called the applets, but we know how it finished, right? Okay, so if we try to find the place for TypeScript between those, we will see that TypeScript is strongly typed because we define the types, right? It is asynchronous because when we write TypeScript code, we transpile it down into JavaScript. Then JavaScript, the asynchronous one, is the runtime, right? So the runtime of TypeScript source is going to be asynchronous. Then it is object-oriented, right? Because we create classes, we create interfaces, we do inheritance and so on. But at the same time, it's also a functional approach, right? We do have to deal with functions, including asynchronous stuff, as Maciek was previously talking about. Then we have class-based inheritance, not a prototype-based inheritance. And finally, just as with JavaScript, we can create clients and servers. If we take a look at this all, we can see that there are some things about Java, some things about JavaScript, and this is some kind of approach in the middle between those two languages, and hence the title of this presentation, JavaScript plus Java equals TypeScript. Writing in TypeScript requires you to think in both kind of approaches, right? So you can, in some way, you can get the best of both worlds. Okay, and now a different topic. How many of you has heard this phrase before, JavaScript fatigue? Hands up. Okay, and how many of you have found yourself in a situation that your colleagues are introducing tools that you don't know how to use, and you need to introduce it into the whole setup of Grunt, Gulp, whatever you use, and it takes a lot of time. You need to learn it and so on. How many people? Yep. So JavaScript Fatigue is something that you can quite popularly find on Twitter. This is the state of JavaScript, that there are really lots of libraries that solve the same problems, right? In a slightly different way, but there are so many of those tools. So if we want to do templating, then we've got handlebars, mustache, icon has, underscore, Jade, and yeah, most of them are similar, but Jade is a little bit different. Then for CSS, we've got the native CSS. We also have Sass, Compass, Less, Stylus. You can see that those four, they solve exactly the same problem, right? But in a slightly different approach. Why doing this? Again, we've got quite many libraries for doing testing. Well, those are a little bit different in what they do. Some of them are test runners, some of them are assertion libraries. And we've got Require.js, Browserify, and Webpack for bundling. And for building, we've got Grunt, we've got Gulp, we've got like more hipster-like Branch, Broccoli, and we have also the NPM scripts. They all, you know, solve the same kind of problems, but in a slightly different approach. If you want to create a platform that will get all those combined, then you need to spend quite a lot of time on this. And those tools, let's say Grunt and Gulp, are not replaceable. When their authors were creating them, they could have thought about creating the same API, right, with using this so that they could be replaceable, but they're not. If we take also into account that we've got different frameworks, then all this setup is becoming more difficult. And finally, if we take into account that we don't have only JavaScript, but we also have ES6, we have CoffeeScript, and we have TypeScript, right? Then this whole landscape is becoming really complex because we have so much to choose from, and all the setups, if you choose each of them, of those categories, is completely different. And there are no standards. Everybody is doing on his own what he wants, what he needs, right here, right now. If you join a project that is already set up, you need to go through this, right? There are no standards here. So this is making kind of difficult to work in JavaScript for newcomers right now. So you might thought about, why am I talking about this TypeScript if it's making things more complicated? What I want to tell you is we should concentrate on the problems that are in the code, the problems we want to solve, not the tools we use, right? If we think about the tools, then we end up fighting with all this setup, right? And it doesn't necessarily solve any kind of problem, right? If we think about the problems, then we choose the right tool when it is needed. And as you might guess, I think TypeScript does solve some problems. And this is something that my colleague from Denmark wrote me on a chat. He said that please try not to introduce new tools if we don't have a reason to do so. It means that let's say I'm young, I'm still young, and I'm very much into JavaScript, so I learn all those tools and I keep introducing them. Those guys are a little bit older and they don't have, let's say, that much energy to cope with that. If I keep introducing new tools on and on again, they will just not catch up with it, right? This is something we should also think about. It's not only about the code, it's also about the people you work with, right? So if you introduce a tool, always think if your colleagues are gonna just catch up with it, right? This is something that many people forget about. And finally, a tweet I just love very much. It says, steps in mastery of a programming skill. At first, we think, can I do this? Or how can I do this? Then I'm thinking, when I have already implemented something, I think about, how can I do it more easily, right? So the code is lesser, it's less complicated. Then I think about more elegantly, right? Maybe it's not a case of 5 functions, maybe it's a case of 1 decorator, but I need to know what a decorator is, right? And finally, when you become a master, you're thinking, maybe you don't have to do it at all, because you don't need it, right? So again, this is about solving the problems and not thinking about the tools. And syntactic sugar in ES6 ES6 is something that I, let's say, consider a tool, right? Because, let's say, a promise is something that solves a problem, right? And all this ES6 syntactic sugar is just a tool, right? Okay, so when we know that we should concentrate on the problems, not on the tools, let's speak about the problems. So the first and most important problem that TS solves is type checking, right? This is a screenshot of WebStorm. I created a function add that accepts two numbers and it returns a number, right? It's just return a plus b, nothing special here. And if I try to call it add with two strings, it throws an error. Argument type string is not assignable to type parameter type number, right? If I try to do it in the IDE. If I try to do it in the console, I get the exactly same error, right? So this is something very easy right now, but this is a very, very important thing that we benefit a lot from. So inheriting from this, we have less runtime bugs. Because when developing, we introduce bugs, right? We introduce some problems. Some of them might be found only in runtime because this is dealing, let's say, with asynchronous stuff, right? But some of them might be related to the data structures you use or the function calls, that you call a function in a wrong way, right? JavaScript will never find it. TypeScript will. So those problems that might be found in the compile time will be found in the compile time, right? So you have less runtime bugs when it comes to deploy something into production. And you have to write less unit tests. You've got testing libraries. This is, I don't remember, this is chai, I guess. Assert is string, assert is number, assert is boolean. If you want to cover JavaScript with unit tests in a good quality, you should use them. And there is no reason to use it when you use TypeScript, right? You just define that something is of type number, of type string, of type boolean, whatever, right? This problem exists in all weakly typed languages, so it's also Python, Ruby, PHP, and so on. Okay, so another problem that TypeScript solves is low-level refactoring. Let's say that we are creating an application that is not your homepage, something bigger. We create a core, and we would create some modules that will be built on top of it, right? The modules will reuse some things in the core, just making reusable stuff in the core, nothing more. And let's say that we don't have 3 modules, but in terms of enterprise, we might have 30 modules or 300 modules, which is more probable, right? And at some point, a business guy comes and says, okay, I need to change one thing here. Right? And if this is some kind of a data structure or a function that is used, let's say, in 500 places or in 1,000 places, and this guy comes and tells me to change it, then I'm done, right? If I was using plain JavaScript. With TypeScript, if I define the types and if I want to change something, the compiler will just list all the problems. This is nothing new for the people who are working with Java or .NET, but we didn't have this in JavaScript. When working with TypeScript, we do. Another thing, reducing JavaScript pitfalls. Let's say we have a small JavaScript snippet. Var A equals 4, var B equals 5, and var C equals A times B. The result is 20. Now we replace the numbers with the strings. We do the JavaScript WAT things. How many of you have seen the video, JavaScript WAT? Oh, yeah, it's very good. So we try to multiply the strings, and we've got an odd number thing, which, of course, is something completely stupid and should not be executed, right? At least we should, when we try to do such thing, we should be notified that we are doing it, right? At least if I did an accidental mistake, and at some point I would try to multiple strings, which is not my intention, I would like the computer to tell me that, hey, come on, this is not what you intended, right? And with TypeScript, I get it. I define that A is of type string, B of type string, and C of type string. And I get the whole list of errors that are here. First of all, the number is not assignable to type string, So I can't perform, like the result of multiplication cannot be a string. This is one thing. Another is that a string cannot be the left parameter of the multiplication, and a string cannot be the right parameter of the multiplication, right? So this is quite obvious, but if we don't talk about strings and numbers, and we talk about really big objects that are returned by RESTful API, then you would see the difference in practice, right? When it becomes really big. Okay, and TypeScript serves something that is called inferred types. So if I create a variable and I assign a string, it will infer, it will just reason that this is a string, right? So it will just know that this is some kind of integer, right? And this, because this is a multiplication, and these are the strings, so I can just omit it, and it will find all the errors. Next one is disabling JavaScript hacks. Let's try to understand what is written here. We've got a module that we would like to import. Let's say it's either Node.js or it's code that is going to be browserified. We've got a function logic that is doing something. And this function logic would like to use this module at some point. And we've got the module exports, and there is a function that either uses the module or requires the module dynamically. And finally, it just calls the logic function. My question to you, how do you think what this code does? Don't be shy. Give yourself a chance. A small hint, this is a very dirty hack, yet possible in JavaScript. So, this code is allowing you to create cycle dependencies that work, right? Cycle dependencies are evil, right? Because you don't know when to stop this, and this is a let's say approach that you can create that the cycle dependency will end at this point, right? It will not execute this code before it is being executed in the runtime. So you just end there. The cycle is being stopped, and when the code becomes executed, then this part becomes executed. So with JavaScript, you can create cycle dependencies which are evil. And when we've been moving our JSON schema faker library, we found a place like this, and this was a stop when I couldn't just carry on with the migration. And I had to solve it somehow. And to solve it, I had to refactor 3 or 4 very big files in order just to move the code, just to remove the cycle dependency. And actually, on one hand, I was blocked to do the migration. But on the other hand, I'm happy that I was blocked, because this is wrong, right? This is not how this should be done. So TypeScript will not allow you to do some of the very dirty hacks that you can do in JavaScript. And one more, it's native modules. So in TypeScript, you can just create a module, name it, do the curly braces, and define the stuff inside there. In JavaScript, you can do the same, but it will just be bigger, right? We don't want to pollute global scope. We want to use modules. But I think this is just easier to write it this way instead of writing it this way, right? Especially that this is quite difficult to reason when we look at git diff, right? Or svn diff and so on. And finally, the last but not least, big business logic under control. Again, let's say that we are building a big application and we need to maintain it. After working on it for 5 years or 10 years or so, the business will come and ask you to extend it, right? And the question is how to deal with all the, JavaScript logic that is not typed anyhow. And design patterns to the rescue. How many people know what is design patterns? Cool. And how many people know what is domain-driven design? Okay, quite much. Perfect. For those of you who don't, I would try to say it in one sentence. No, I will not. Let's say that we are doing a hospital or medical application, and we need to deal with doctors, illnesses, hospitals, appointments, payments, and so on. And this has nothing to do with Ajax, nothing to do with Angular, nothing to do with, I don't know, promises, whatever. This is just pure logic, right? This is the domain logic. And we call it the domain, right? And domain-driven design is just some kind of approach, getting some design patterns to make it easier, just to have all this logic under control. So, and we will just go through an example of this one and of this one. So, in domain-driven design, one of the easiest thing is a value object. Let's say that we have this core stuff, we have lots of modules, and we have a price. This is a thing that exists in the system, a price, right? So when we pay, we need to have a price. When we sell something, we need to have a price. When we have a bill, we have a price. And this price thing is used in hundreds of places throughout our system, right? Let's say this is like 500 times or 5,000 times, which is more probable. And now, there comes a guy from a business and tells us that from now on, we don't support one currency. We support 2 or 3. And we need to change all these 500, 5,000 places that we use this variable in, right? We want to have a currency right now. And in JavaScript, this is something, let's say in practice, undoable, right? Because you would need to go through the system to test everything manually, right? And for a big application that has at least 5 years, this is something like very, very difficult to do. And with TypeScript, if we create a definition that the price is going to be a number, whether it's just a declare type price or interface price, it doesn't matter if it's a variable or if it's an object in terms of TypeScript. The important thing is that you don't do var price number, right? Because this is just a number. You create something special for it. Even if you don't need it right now, you just wrap it with a special type. Because if you extend this type, you'll be good to go in the future. Let's say if you wanted to replace a number with an object with 2 attributes, TypeScript will find all the places that is being used, just like with Java or C#. It's exactly the same way. And yeah, we just add amount, or we extend this interface with currency. Another design pattern that we can use with TypeScript is data transfer objects. This is strictly about either REST, AJAX, or WebSockets, or whatever kind of communication client server we use. So when we shoot a JSON, when we shoot an AJAX request, we expect to have some kind of JSON, right? We expect to have something very specific. And this is about doing a communication contract, right? When I shoot a request into a certain resource, I expect to have a very specific JSON. And I can get it under control using TypeScript. So let's say that I have a get/customers/ID. I have a resource like this. And the objects I will get from it are of interface. First name string, last name string, age, number. Let's say that I just have a system like this. I extend it with get customers. So I will get not a single customer, I will get a list of customers. So I just define that there would be a type customer list, which would just be a customer array, right? Nothing very special here. I also add that for each customers, I can go deeper and get the address of this customer, so that I can create again an interface address with a street, city, country, and extend a customer entity with this addresses array, right? This is something very easy. And the way we use it is that we call the getAsyncData function on some kind of URL method, right? Whether it's Jquery, Ajax, or Angular, or whatever shiny, beautiful library you use. And in the callback function, we get the customer response. We define that it's going to be a customer, right? The one that we have created before. And when we process it on customer first name, it's OK. On last name, it's OK. On name, we get an error, right? Because this is something that does not exist on this interface. So we get an error, and this is what we want to do. This is what we want to get, right? If we create a contract basing on TypeScript, then we can find all the places that we are about to misuse the response, right? Again, in big scale, this makes a difference. You can believe me. Okay, so There are no silver bullets. There are no tools that solve all the problems. Of course, there are problems that TypeScript doesn't solve. First of them is just mistakes. TypeScript will not solve your logical mistakes. It will not solve the problem of lack of knowledge. An example is if we create a race condition using promises, for instance, Ajax calls, TypeScript is not, it's not possible to find such kind of problem, right? So it won't solve, problem of hunger in Africa. Next thing is that when you use TypeScript, you are not allowed not to understand what is going on in JavaScript, all right? You need to know what is JavaScript about, because if you don't, then you misuse it. It's a disaster, right? So you need to think about what output will TypeScript provide. And moreover, when you write and read TypeScript code, you need to think of it in, let's say, parallelly two types of thinking. One is thinking in terms of OOP, right? Because this is classes, interfaces, inheritance. And the second one is asynchronous runtime, right? So you need to think in two ways. Next, TypeScript will not make it faster. It will not make it faster to write the code, and it will not make your application execute it faster, right? Because this is still the same JavaScript. And in fact, when you write the code, you might write a little bit more code because you define the types, right? When the output is created, the types are just stripped. They're just put away. Their value is that when TypeScript loads the code, it just parses it and logically tries to reason about the code, right? And when it sees some contradictions, it will just notify you with errors. But the JavaScript code does not have them, right? So TypeScript will not speed you up. Maybe it will speed you up in terms of having less bugs and less problems in runtime. And finally, there is the any type. The any type is a special type that allows you to put everything into it. So this is something, let's say, contradictory to Java or C# and those languages that expect you to define everything. In terms of TypeScript, this any type is needed because if you want to migrate JavaScript code into TypeScript, which is strictly typed, sometimes it's either very, very difficult to migrate, some kind of, magical hacks, or maybe it would be even impossible if you use eval, which is evil, right? So there are some certain places that you need to use any, but there is a temptation to overuse it. And this is the problem with any. So we can define any explicitly just stating here, semicolon any, and now TypeScript will not have this variable under control because anything can be there. Or it can be inferred, so that TypeScript will, we will not state that it's any, but it will reason about the code. In this example, we have a function that accepts two parameters. One of them is used in terms of being an array, right? We push something. And the second one is just something, right? So it infers that this is of type any. So this any can be explicit or implicit. The problem with any is that, it's very easy to use, right? We just type any and we forget about the thing, and we hope that the code review will not, get back with the request to remove it. So it's very messy to use, and it's very tempting to overuse it, but sometimes you just can't do without it. So if you use it too much, it can be very dangerous for you, just like overusing donuts. Okay, As we all know, nothing comes for free, right? If we get some benefits, we have to pay for it somehow. So the price we pay on using TypeScript is that it introduces some overhead, right? This is obvious, right? Everything introduces overhead. The biggest overhead, in my opinion, is that automation becomes more expensive. Whether you have Grunt or Gulp or Webpack or whatever, if you need to transpile TypeScript down to JavaScript, then you have an additional, let's say, step that you need to perform. If this is one-to-one, then this is not a problem. This is quite straightforward. But if you split your application into bundles, then it's starting to get more complicated because those bundles will be compiled separately. And if a bundle needs to load some kind of interfaces from another bundle, then your structure needs to be like ready for this, right? So this is not a very big deal, but you need just to take it into account. Of course, it depends on the size of your application, but there is some overhead. Next thing is if we're using third-party libraries, let's say Jquery. It's written in pure JavaScript. If we want to use Jquery with TypeScript, then we need to specify what is that, like, of course we can use any, right? But this is not the case we want to do. So we would like to have the definition of what Jquery is. So we've got something that is called definitely typed or typings. This is a set of definitions of the things that are done in JavaScript. It's just mapping to TypeScript interfaces. We use them a lot. There are some, let's say, there might be some less popular libraries that don't have those, let's say, coverage with definitions of TypeScript. But it's very rare. Yeah, but anyway, again, this is something that you need to care about. Another one, your teammates need to learn TypeScript. If you think about introducing it and you think that it solves your problems, this is something yeah, very good. But keep in mind that the people that don't know it will just come to you and ask you questions. And this was, especially in my case, I had to do lots of explaining over and over again. The good thing is that the entry level is quite low because the syntax of TypeScript is very, very similar to JavaScript, but yet there are some questions, right, you need to answer. And finally, debugging might be a little bit less convenient because the source of your application is TypeScript, and the output is JavaScript, right? So the code you write, the code you work on, is not what you debug. This is not a big case because the output of TypeScript is very similar to the source, but it's just not the same. So you need to think about a map file, or just need to think about that this line in the debugger is that line in the source code. This is not a big deal, but, well, for some people it might be. Yeah, so these were the problems that that TypeScript solves, and that TypeScript doesn't solve, and the ones that it introduces. And now let's see how TypeScript finds itself among the rivals. So first of all, JavaScript is the default choice, right? This is the native language that all the browsers support. A good alternative is ES6, because ES6 is gonna be here, right, within some time. And ES6 introduces quite a lot of stuff like classes, generators, I don't know, some kind of arrow function, and so on and so on. But actually, all those things are just syntactic sugar on top of what is really going on in the JavaScript engines. At least V8 is not creating classes in the engine. This is just syntactic sugar, right? It's easier, of course, to write. It's better to write arrow functions rather than doing all this stuff, but it's just syntactic sugar. Keep that in mind. And with TypeScript, we get a whole new level of abstraction, right? We get the type checking, we get the compile time. ES6 doesn't have it, right? And TypeScript does. Moreover, TypeScript is being transpiled down to JavaScript anyway. So TypeScript is not doing it to ES5, it's doing it to ES6 mostly, right? Because they can think about the TypeScript syntax whatever they want to think about it, right? So they can just support all this. So you don't have to, you don't lose all those features like arrow functions, modules, and so on. So you can have both when using TypeScript. And finally, there is this old pal, CoffeeScript, which I honestly don't think is any kind of alternative right now. Actually, when doing our bank project, we have started using CoffeeScript. The main reason was that development in the long run will be a lot faster. It is, if you know CoffeeScript. And the syntax is completely different than JavaScript, providing that you don't know Ruby. Because if you do, then it's easier. But if you don't, it's a completely new language that is somehow crazy. The second reason was that, well, at some point, we can drop CoffeeScript, transpile it down to JavaScript, and carry on working on JavaScript code, right? If we want to quit, we can just transpile it and carry on. And these were the reasons that we convinced business to carry on with CoffeeScript. At some point, we tried to migrate to TypeScript, and when we took a look at what a production, let's say, big application CoffeeScript code might be, then it was really hell. It was something really, something you would never like to to look at. So, well, CoffeeScript was good in introducing some kind of, arrow functions and those things. It was really good. It's already adapted in ES6. And in my opinion, this guy has done its good work, and now he can just leave. So these are the languages that I would just choose from at the moment. Okay, so yeah, one more thing. One should choose TypeScript for development of any new project. This is a Boolean expression, right? So my question is, true or false? Yeah, who is for true? Okay, and who is for false? Okay. So when you want to be smart, or when you want people to think that you are smart, when they ask you a difficult question, the answer should be? Who said it? Who said it? You? Yeah. This girl deserves a t-shirt, if you have one. Exactly. It depends. It depends on things like what is the project size of your application, the size of a project, and it depends on the people you work with. If you work in a dynamical environment with young people that are eager to learn and so on, then they will adapt to TypeScript quite fast, right? Because they're interested in it. But if you work with people that are not really interested in anything that is new, then you will have to struggle with them, right? So this makes a difference. And you benefit from TypeScript the more, the bigger the application is, right? So even if you have small things, I would go with TypeScript, but the bigger the application is, the more you will benefit. There is another great tweet by Tomasz Nurkiewicz. He says that writing in dynamic languages is faster. So writing in strictly typed languages is slower. But most of the time, we read code, not write code, right? And in strictly typed languages, it's easier to reason what is going on, right? And this is what we do mostly. So do the math, whether you prefer to work with JavaScript or TypeScript. This is, this is a question whether it's worth to go with TypeScript or not. This is a question each of you should just answer yourself in terms of each project separately. Yeah, we know that all decisions have pros and cons. There are no silver bullets. And finally, whether we want to transpile some kind of languages into JavaScript. The things that you can ask yourself about is what are the pros? What are the pros? What are the cons? You might have more features, might be less code, better efficiency either of the language or your work, or just following new trends. But there is more complexity, higher entry level for newcomers, the IDE support, the platform support, more complex setup, and so on. And finally, how to answer your question is pretty straightforward. It's just whether the pros you get is just bigger than costs of introducing such thing, right? So in terms of your application, if those things are bigger than those, then just go with TypeScript or whatever other tool you are considering. So just last slide from me. The main ideas, right, is think about the problems you want to solve, not the tools. This is very important. Always be responsible for the tools you introduce. If you introduce a tool into people that don't want to use it, then you need to be strong enough to succeed with it. Nothing comes for free, right? There are no silver bullets. AngularJS is not gonna make your application be executed faster. This is a lie. This is gonna make your application development easier, but it's not gonna make it faster. And so with TypeScript, it's not gonna solve all your problems. And finally, everything has pros and cons. So this is all I prepared for today. Thank you. If you want to get in touch with me, I'm very happy to do so. You can follow me or on Twitter or tweet me or just write an email. I'll be very happy to answer you. And maybe we have some time for questions?
Sure we have. Any questions then? Okay, there are 2 questions. You were first.
You've mentioned interfaces in TypeScript, and that's a thing I've been personally wrestling with for the last few years, having found no suitable solution really. So I'm gonna ask you this. Do you get dynamic checking with interfaces in TypeScript? Or is it static on compile time only? Because I found myself in situations where I have successfully implemented interfaces using symbols or so, but then I've had problems that requiring the same module, or rather multiple copies of the same module, would mess with the symbol hierarchy. It was not the same symbol, even though it was the same package. For instance, it was another version, so a new copy of the directory, and you did not get strict equality. So the implements check would not match, and so the question stands. Do you get dynamic, or so duck typing, or static symbol-based checks in interfaces?
To be honest, to answer your precise question, it was somehow so complex that I would need to see the code, but more or less, TypeScript is introducing compile time, right? And it analyzes, it passes the source code, and the whole idea, the whole goal of this compile time is to parse the code and jump, transpile it down into JavaScript. So your question is whether it is possible to do some kind of type checking in the runtime. So you mean in JavaScript? Because TypeScript has no runtime, right?
Yeah, whether if you pass some value to a function and you just duck type it, so say it's an any type, does it help you in any way with checking its properties and determining if it fits the interface or not?
I think you have already answered both of your questions, because if you define a variable with an any, then you can't have the types under control, right? You use any in very specific situations when there is completely no other situation, or let's say removing the any might cost you, I don't know, 2 days of work, right? Because the JavaScript existing code is so messy. And regarding the runtime type checking, the only possibility of doing runtime type checking would be that you define something in TypeScript, and TypeScript would generate a whole lot of additional code that would check your types in the runtime. This is the only possibility, and this is not TypeScript approach. This is what you don't get. So I would need to take a look at the symbols code that you are struggling with. Maybe you can just send it to me, but this approach is completely like out of scope of TypeScript. TypeScript will always try to find all the errors it might find in your code. So let's say on one end of the application you define that a variable is a string, let's say, and on the other end of the application, let's say 100 files away from there, you expect a number and you just try to pass it. TypeScript will find such thing, but it will never, generate additional JavaScript code that would do any type checking in runtime. No.
So yeah, static type inference, got it.
Yep.
Hi, thanks for the presentation. This was really great. I wonder if you ever used Flow. It's something like type checker for JavaScript, and if so, how would you compare using Flow and ES6 maybe and TypeScript?
That's a tricky question because I have never used Flow. So
okay, so
yeah.
No.
Sorry, we have time only for the last question here. So thanks a lot.
Thank you.
For the presentation.